Hi everyone. So, uh, okay. Today I'm going to talk about smart contract automation infrastructure solutions. So we will explore Chainlink automation, Gelato automation. Maybe if we have enough time, we will talk about Open Zeppelin solution and Tenderly solution. So first of all, I want to talk a bit about smart contracts. So, as people from industry know that smart contracts have emerged as a highly secure form of digital agreement with the power to transform global industries and from relatively simple use cases of digital money to a more complex paradigm of decentralized finance, like decentralized exchanges, lending, and insurance protocols. At their core, smart contracts are self-operating computer programs that strictly carry out contract terms if conditions are met. When it and So they strictly carry out contract terms and if conditions are met and when it is necessary to do. So unfortunately, smart contracts are not fully automated and therefore cannot execute their own functions based on predefined conditions on time or on some rules. Instead, smart contracts must be triggered to execute. And you can think about smart contracts like a program on your computer, which is waiting for activation. And blockchain industry is constantly evolving, especially the infrastructure landscape. And so nowadays we have a solution for the automation problem, and it's called Smart Contract Automation Infrastructure. This is where Chainlink Automation, Gelato Network Automation, and Open Zeppelin Defender and Tenderly Web3 Actions step in. These solutions act as a vigilant guardian, checking execution conditions of smart contracts and ensuring smart contracts execute timely based on set criteria. In other words, through automation, smart contracts functions can be activated without human intervention, without manual human intervention. And today we will explore these automation solutions. Um, okay, so let's deep dive a bit more into smart contracts. So smart contracts, as I said, a program that is hosted and executed on blockchain network. Each smart contract consists of code specifying predefined conditions that, when met, trigger some outcomes. By running on a decentralized blockchain instead of centralized server, smart contracts allow multiple parties to come to a shared result in an accurate, timely, and tamper-proof manner. And smart contracts are good candidates for automation because they're not controlled by a central administrator and are not vulnerable to single points of attack by somebody. And also, I mentioned the most important things about smart contracts on the slide regarding to automation. So smart contracts are hosted and executed on blockchain. Contract code specifies some terms and carry out them when conditions are met and when it is triggered to do. And the most important thing here is contract logic can be triggered by some external account, for instance, some wallet, presented by a key pair, a private key and a public key, or by another contract. But this trigger can be done only inside a transaction that somebody will sign and send to blockchain. So so everything is okay. So you hear me and you see presentation. I will double check to be sure. I will look at the chat. Okay. So I suppose everything is okay. So next topic. So why smart contracts need automation? Um, so basically, smart contract automation allows developers to trigger smart contract functions in automated way. And to better understand the wide-ranging benefits of smart contract automation, let's establish a working understanding about the problem which exists. So the problem is that smart contracts cannot auto-execute. I have already talked about it a bit, and smart contract code usually states such rule: if the condition is met, allowed to execute some action. However, smart contracts are not self-executing, and somebody needs to trigger to call smart contract function by sending a transaction. And of course, there is a solution to trigger smart contract functions in automated way before such infrastructure solutions like Chainlink or Gelato, for instance. But it was a bad solution. So a bad solution for automation is a centralized automation server. For instance, usually developers implement some kind of a cron job or a centralized server with some tasks queue, which will implement, which will periodically call smart contract functions. But it is a centralized server, so there are some consequences. In such a setup, automation server becomes a centralized point of failure. So that introduces risks around the execution of smart contracts timely. So, and this can lead to some exploits and miss opportunities. Speaking about a good solution, the good solution is a decentralized automation network, and at such solutions like Chainlink and Gelato, there is always such entity called like a keeper, or executor, or bot. And these entities are incentivized to trigger the execution of smart contracts through transactions based on predefined conditions. And these conditions are defined in such entity called like a job, or another name is upkeep, or another name is a task. And these jobs, tasks are submitted by development teams to a decentralized network of these bots. And so these jobs can be submitted by a development team or by a DAO or by a protocol user, doesn't matter. And these jobs always include a condition for automation, and usually this condition based on time for instance, trigger some function every day at 5 p.m. Or it can be some on-chain condition. For instance, a smart contract can implement a function which will be called by these keepers, and this function can implement logic. For instance, like it is allowed to execute some logic when, for instance, some token price crosses a certain threshold or certain target price. So if this condition is met, keepers bots from decentralized network will execute some logic. Okay. And how it work? How it work in more details. So on this slide, you see two schemes. First scheme is centralized automation solution, and the second scheme is a decentralized automation solution. And I will talk in details about that decentralized version. So, as I said, there is some network of, or there is a decentralized network of keepers bots that are incentivized to trigger the execution of smart contracts. And I have already said about conditions. It can be a time condition or some on-chain law condition, some complex condition, for instance, crossing the target price. And these bots from this network check conditions every block in blockchain, and so they call smart contract function that is responsible for condition, and these bots call this function every block, and when conditions are met, this function should return true. In opposite, return false. And once this function returns true, then these bots, one of these bots, and it can be selected. So the bot from this decentralized network can be chosen according some approach. Maybe some random approach or maybe some more complex approach. And one of these bots calls execution function, and the logic is executed. So yeah, that's it. In first, that's it without a deep dive. So let's go to the next slides, and we will return to learn more about certain implementation in Chainlink and Gelato. But first, I want to talk about different use cases for automation. There are a lot of use cases, and I listed on this slide the most interesting use cases. For instance, using smart contract automation, projects can trigger some automated payments. For instance, some Web3 company can set up a payroll contract that will be responsible for paying salaries for contributors and employees based on some conditions, and it will be in automated way. The next interesting use case we can talk is for instance, mm, uh, dynamic NFTs. Maybe somebody is familiar with such token standard called NFT, and NFT is some token with its unique token ID, which has some metadata hosted in IPFS network. And this metadata holds the NFT image and NFT traits. And using automation, it is possible to, according to some condition, update this metadata. Without automation, it is not possible or difficult to periodically update the NFT's metadata. For instance, update the image or some trait. You can think about, there is an interesting use case of NFTs, a gaming asset. So you can imagine some game in which assets will be implemented using NFTs. For instance, some knife, and this knife can be upgraded during gameplay. And after each upgrade of this knife, some traits of this knife will change. Maybe the appearance of this knife will change. So it can be automated using automation infrastructure. Also, there is. I will discuss one more example. For instance, limit orders on decentralized exchanges. Maybe somebody here is familiar with the concept of DEX, a decentralized exchange. So decentralized exchange is a peer-to-peer marketplace that enable seamless exchange transactions without intermediate, without third party. And most powered with AMM protocol. And AM is the concept of automatic market making. And using AM, DEXs can implement self-governing trading mechanism. And there is a concept of liquidity pools in DEXs. And liquidity pool is used so users can deposit their tokens into liquidity pool and get some share of trading fees at this DEX. And speaking about DEXs, there is a problem. There's one limitation in DEXs that there is no order book on DEX because all exchanges made using atomic transactions, and you don't need, for instance, if you buy something, you don't need some person which will sell you something, because this exchange will be implemented using AMM approach. And that is why there is no order book on DEX. So where people can make orders, for instance, buy orders or sell orders, and that is why traders are forced to wait for the desired price, and they can't create a limit order and just wait and set the target price and receive exchange in the future. They need to wait and make an exchange when the target price is achieved. And this was This limitation was doesn't exist now because there are a lot of automation solutions. So users can specify their target buy or sell price, and automation network will use some off-chain computation and which will continuously monitor asset price on DEX. And when user's target price is reached, automation network will execute the transaction on their behalf. So with automation, users no longer have to sit at the computer for hours until their desired target price is reached. And there are some real world examples of decentralized exchanges that uses automation, and usually it works like this. So there is some DEX, and when user creates an order, it creates a task for this decentralized network, and this task has some condition, and when this condition will be met, one of the bots from this decentralized network will execute, for instance, exchange function of the contract, and user's limit order will be executed. Okay. Let me check the chat. Okay. So that's it about use cases. Let's talk about solutions, automation solution. The first automation solution which we'll explore is Chainlink automation solution. And Chainlink is not only about automation. Chainlink is a decentralized platform that provides full connectivity and off-chain computation for smart contracts. There is a limitation of smart contracts that they executes in sandbox, and smart contract doesn't know anything about this other world. A smart contract can't make an API request and etc. And Chainlink have different products that which allows to provides Web2 connectivity for smart contracts. For instance, make an external API request or using an Oracle network to get some data from Web2 world. Web2 is a classical the internet. So with all the sites, web services, and etc. And Chainlink have different products for this. The first product is a data feeds. So it's a decentralized and highly quality data feed, and it can and data feeds are different. For instance, it can be a feed with some sports data, or maybe with um, some prices, for instance, prices for public companies shares, and etc etc etc. And so under the hood, data feed is implemented using an Oracle network, which grab the data from Web2 and commit this data to Web3 to blockchain. Also, Chainlink has have brought a product called Functions. So Functions allows to connect smart contracts to trust minimize compute infrastructure. running on this decentralized network. Also, Chainlink has a CCIP product. So it's a cross-chain interoperability protocol. So this protocol allows to connect different blockchains so they can communicate. And this communication is not limited with transferring different tokens from blockchains. This protocol allows to smart contracts from different blockchains to communicate. So one smart contract can call some function from another contract, which is deployed on another blockchain. For instance, one contract is deployed to Ethereum and the second contract is deployed to Polygon. And the last product by Chainlink is VRF. It's a verifiable, tamper-proof, random number generator for smart contracts. There is a generation of random number in blockchain using smart contracts is a difficult computational problem. So the VRF product allows to get this random number. And so it is about Chainlink, but let's deep dive into automation by Chainlink. So automation is a decentralized transaction execution solution that enables smart contracts to automate key functions. And it can be automated in highly reliable, trust minimized, and cost efficient manner. So how it works? Let's see. There is a scheme of Chainlink automation solution implementation. So Chainlink automation uses a decentralized network to monitor smart contracts logic securely and cost efficiently. And then this network can initiate an on-chain transaction to execute the smart contract when some predefined conditions are met. Here we see in off-chain section, we see these automation nodes, and automation nodes have an access to tasks queue, and they nodes from this automation network checks conditions and make transactions once those predefined conditions are met. And on this scheme, we see that there is an upkeep contract. So this is the contract that we want to automate. And this contract should provide some function. And usually this function is check upkeep. And this check upkeep function implements some logic. For instance, logic with if we speak about limit orders on exchange, so this condition can implement logic with which checks if the target price from limit order was reached, and when this condition is met, check upkeep should return true. And once this function returns true, then nodes calls that function on chain, and and now we need to look to on-chain part of this scheme. When, as I said, when conditions are met, some keeper, some bot from this network will call a function provided by upkeep contract, and usually this function is called perform upkeep. And so this function will be called by sending an on-chain transaction, and this perform upkeep function should implement some logic. And again, speaking about limit orders, it will be logic of exchanging completion this limit order. So limit order, according to limit order, one token must be exchanged to another token according with some price. So this perform upkeep function will execute this logic, and the result of this execution will be token exchange. Okay. Uh, so so this is the approach which Chainlink Automation solution uses. Speaking about Gelato, Gelato is very similar solution. It also some kind of decentralized backend, which allows to connect some contracts with Web2 world. And Gelato also have similar products. For instance, Gelato has a Web3 functions product. Of course, Gelato has an automation product, and also Gelato has a relay product. And the architecture of Gelato Automation Network is similar to Chainlink. There is some a decentralized network, and in case of Chainlink, we had network of keepers. They are called keepers in Chainlink, but in Gelato we have checkers and a checker role and an executor role. So so um, checkers has access to tasks queue, which developers creates for instance, this queue will have a limit of orders. And checkers, there is a very similar approach. Uh, checkers call some function which is provided by contract which we need to automate. And if this function returns true, then checker communicate this to executor, and then executor executes logic which need to be performed. So it's very similar approach to Chainlink. And speaking about automation options which Gelato gives, there is a time-based automation. So you can set up some in form of cron, you can set up some time-based automation. Also, Gelato allows to create custom logic-based automation. It is when logic is implemented on smart contract. Speaking about time-based automation, it can be configured via UI or SDK, and custom logic-based automation also can be configured via UI or SDK. But custom logic automation can be also configured using some on-chain logic. So you don't need a UI or SDK to create a task which will be automated. And if we come back to automation solution, there is also a time-based automation option and custom logic-based automation. It is very similar to Gelato. There is also a scheme of Gelato automation solution. Here we see checkers, executors, and but we are not going to deep dive into this. It is better to to practice and to implement some automation logic during our coding session. And during coding session, we will use the automation solution from Chainlink. But first, I want to stop and ask listeners if everything is okay, and maybe you have some questions. I will ask you questions about the theory, and if we finish with all questions, we will go to the next step, and we will have a coding session. So maybe somebody have some questions. You feel free to ask me. Okay, nobody have questions. Okay, so let's code. Um, I'm going to automate a simple use case called payroll contract. So payroll contract is a contract with the terms of the agreement between employer and employees. And this contract, I want to automate this contract to streamline the process of paying salaries, bonuses, and other compensation to employees. And and this payroll represents a simple contract through which employer can hire an employee and conditionally um, and make regular payments for their services. Of course, this will be implemented in a very simplified form without complex conditions and corner cases, such as vacations, sick leaves, and etc., day offs. It will be a very simple implementation, but still very using using this contract. Employer can hire an employee by setting contract details, such, for instance, contract duration, the duration of the reporting period for which payment is due, for instance, 1 month, 1 week, 1 day, or even 1 minute. And of course, usually employees have a contract and they have a recurring payment for 1 month. But for demo purposes, we will set the the duration period for which will be payment executed for 1 minute. Okay. On this slide, you see two pieces of code written in Solidity. And I will explain this. So to implement this payroll logic, we need to store employees on smart contract with corresponding contract parameters, and this will be stored in the storage of smart contract in EVM, where Solidity smart contracts are executed. Storage is a persistent memory of the contract, so it will be persistent between different transactions. And also we will implement several functions which will be used for managing employees and for making payments. And here we have three functions: hire employee, check next payment function, and make next payment. So high employee function is we need this function to make a contract between employer and employee, and check next payment function checks the need for next payment, whether and the logic implemented in this function checks that contract between two parties is active and the reporting period has passed. And this function is a read function, so this function doesn't mutate the contract state. This function will be called by keepers or bots from Chainlink decentralized network. And when this function returns true, this is a sign for keepers that they need to execute next function, and it's and this is make next payment function. So this function is responsible for making direct payments for the reporting period from this contract. And this function will be a write function, so it mutates the state of the contract and of the entire blockchain. So this function is write, so when it's called, there is somebody need to sign and send on-chain transaction. Otherwise, this function can't be executed. So, in general, this contract already can be used by contract administrator, but without automation, contract administrator need to manually call the functions. For instance, one employee worked 1 month, and the contract administrator wants to pay this employee, so it goes and calls check next payment, and if 1 month passed, check next payment function will return true, and this is the sign that administrator can call make next payment function and make a payment. But it is but if we imagine that some company has 200 employees, it's almost impossible to manually administrate the process of making payments for employees. So we'll try to automate this. So let me demonstrate my 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 editor, code editor. Okay. So now I will share my entire screen. Yeah, so I see that it works. So I have a project which I called Automation, and for people not familiar with smart contract development using Solidity, this is a boilerplate project created using such tool called Hat. And this tool is for writing, testing, and deploying smart contracts on Solidity. And the structure of this project looks like this. So we have a contracts folder. Here we have a payroll contract. I have already showed you some pieces of code for this payroll contract, but let's look again. So here we have a employee struct. Each employee has different properties: status property, payment interval property, payment amount, and etc. etc. And we have a map structure which holds this employee, and the map, so you can, it's like a hash or object where address is the key and employee is a value. And also here we have two functions, hi employee, check next payment function, and make next payment. So hi employee will add employee to this smart contract with all these properties. Check next payment function is responsible for implementation of condition. And if we look at the logic here, this condition checks that the contract with employee is in active status. And also it checks that the difference between last payment and current timestamp in blockchain is bigger than payment interval. So payment interval is a interval in seconds for interval for which the payment will be made. It can be 1 month or 1 week or 1 day even. But in our case, we will use 1 minute interval because we need to simulate the real world use case, but we don't have enough time for this, so I will use 1 minute interval. So if difference between last payment and current timestamp in blockchain is bigger than 1 minute, this is the sign that this is the reason to make next payment. And make next payment function is responsible for making a payment. And here we have 2 lines code which transfer employee address the payment amount. So that's it. So let's deploy this contract to blockchain. Okay. I have prepared some scripts for this, so I don't need to do it manually. My script will deploy the smart contract for me from my admin account or wallet. So let's run this script. Okay. I still have some listeners. It's good because I thought maybe somebody left. Please write me something to the chat if it is interesting for you, if my talk is interesting for you, because I need some feedback. Hello, guys. Okay, somebody is interested. So I deployed this contract. In the console, I have an address of my payroll contract. So there is a tool called Polygon Scan, and we will use this tool to read data from blockchain. So we have a address of payroll contract. It was deployed 1 minute ago, and here we see some read functions, and here we see some write functions. Let's add a first employee to this contract. I have a function, a script for this. It's called employee, and I will call it. I will run it. I want to hire, for instance, there is my MetaMask account, and I want to hire this wallet, this employee. It has this address. I want to hire him. So I'll insert his address here. And also I need to copy payroll contract here. So, okay, my script is ready. I will run it and we'll add first employee to our smart contract. Okay, so this is the hash of transaction. Okay. So I created a transaction from my admin account. We called high employee function of payroll contract. And when this transaction will be mined is when transaction got to some block. A first employee will be added to the contract. We see that 30 seconds ago, this transaction was executed. So if we go to read contract methods, here is an employee map getter. And if we pass here the address of employee, we will get the employee object. And let me rerun. Yeah, we see this employee here, but why I see the zeros? Something wrong. Let me check. Yeah, so I called this function with payment interval 60 seconds. So I want to pay this employee every 60 seconds, and payment amount is this amount. Okay, so everything is okay, but why I don't see employee here? Okay, doesn't matter. Let's make a pay. Sorry, let me check. Oh, sorry, I use wrong address. Yeah, this is the address of employee one, and we see his object here. So everything is okay. We hired one employee. If I call check next payment, this payment should return true because this employee already worked 1 minute. So me as a contract administrator need to pay him salary. To do this, I can go to write contract tab and I need to call function make next payment, and I will make payment for him. But I will do it firstly manually and then I will automate it. I will go to my MetaMask wallet and change active account to admin account. Go back to Polygon Scan. I will connect Polygon Scan interface to my MetaMask wallet. Yeah, it's connected. So now I can call this function, make next payment. I will pass employee address, click this button, and sign transaction. Okay. Oh, sorry. I choose wrong. I think I choose wrong account. Let's try again. Okay. So no, I don't want to use automation account. Let's try again. My automation account ends on D3, so let's connect again. Whoa, why the address doesn't change? Give me a second. Give me a second. Clear cookies. Let's do it again. More contract, write contract, connect to Web3. Okay. Very strange. Give me a minute to figure out why Polygon Scan doesn't want to use my actual active wallet. Give me a second. Okay. Mm, mm, Okay. Let's try again. This is very strange. CF. Okay, let's use another automation account for this task. Give me a second. Let me stop for a second demonstration. I need to change the private key of my admin account. Okay. There is private information, so I need to stop presentation. So, okay. Okay, let's share again. So I changed my admin account. Sorry for this. Okay, but I need to uh, redeploy my payroll account. It will be fast, but I need to prepare some money. Okay. As you see, blockchain development is a very difficult thing. Some problems occurs. Pa-pa-pam. I need some native token called Matic for making transactions. So I need to wait a bit. Okay, everything is ready. So let's start from the beginning. So we need to deploy payroll contract. Let's do it again. Wait a little. Okay, payroll contract was deployed. We'll open payroll contract on Polygon Scan. It was opened. And then I need to hire employee. I will update payroll contract address, and then we'll copy employee one address. We want him to be hired. Okay. So the contract was successfully deployed. We can see the source code of the contract. Then we need to hire. I update employee address ends on FB4. Okay, let's run this script. Okay, transaction was executed. When this transaction will appear here, so the employee was added to the contract. Let's update. Yeah, we see here this high employee function. So we can go to read methods, find employee map getter, pass here address of the employee. Yeah, so the employee was hired. If we call check next payment function with employee address, now it will return false because employee was hired only 12 seconds ago. We need to wait a little bit because this logic, check next payment logic, stands that the difference must be bigger than payment interval, which is 60 seconds. Let's look at the 1 minute. The transaction was 1 minute ago, so now so check next payment function now returns true. So we can go to and make next payment. But first, this payroll contract must have some Matic tokens on its balance to make payments. So firstly, I will go to MetaMask and transfer some Matics to payroll contract. I will transfer not a lot because when the payment for the period is this amount, so I think there's enough amount to deposit like this. Okay, let's sign transaction and return back to the contract. We see that the balance was increased, so finally we can make a payment. Yeah. So let's connect again to MetaMask. So finally, it's good. My connected account is similar to my admin account, so everything okay. So let's make payment. We'll copy employee address and sign transaction and send it. Okay, let's do it. In a separate tab, open employee wallet page. Somebody unmuted. You want to say something? Okay, don't want. Okay. I made a payment. So 30 seconds ago, I made a payment, and this amount of Matics was transferred from payroll contract to employee wallet address. So we paid a salary for this employee, but it was a manual task. So let's automate this. Firstly, I want to automate it using time-based automation in Chainlink. To do this, we need to open Chainlink Automation console and register a new upkeep. Upkeep is a bot which will check the condition for execution, and when the condition is met, it will execute some task. So let's create this upkeep. Here I can choose a time-based automation. Okay. There is a field, target contract address. Here I need to pass the payroll contract address, the contract which we want to automate. Okay. If everything is okay, I can choose a target function which will be automated. I want to automate make next payment function. And here we need to pass the employee address. So when make next payment function will be called, employee address will be passed. And I will take employee address and pass it here. Click next. And here we need, in time-based automation, we need to set up a schedule, and it can be set up in cron expression syntaxes. And we can choose 1 day, 1 month, 1 year, but in this case, I will choose 1 minute. So I want to pay salary for the employee every minute. So, okay. And I need to name this upkeep somehow. I will call it employee and use the beginning of employee address. And I will call it employee time-based automation. There is ability to set the gas limit of the execution function and deposit some amount of link tokens for this keeper. And when everything is filled, we can register a upkeep. There is first transaction, which will deploy a cron job contract. And when this transaction is done, there is a second transaction, which will register upkeep in a decentralized Chainlink network. So keepers from this network bots will be their goal to execute this smart contract. Yeah. So let me check if everything is okay. I saw some error. No, we just created 2 transactions, so everything is okay. So I think that our upkeep was created, but we somehow got an error. If we come back to home page, here we will see created upkeep. Created upkeep. Yeah, we see an upkeep here. Yeah, so upkeep was created. And this upkeep must pay a salary to our employee every minute. And all this execute, and we'll see these executions in this history table, but somehow I see some errors here. Maybe there is not enough link tokens on my contract. Maybe I need to deposit link tokens. Of course, I need to deposit some tokens to link tokens for paying Chainlink infrastructure on payroll. Sorry for this, on payroll contract. I will do it. So this is the payroll contract address. I need to send some link tokens. Let's do it. And then created upkeep will be in good shape, and it will not show me these warnings. Let's wait when the balance will be updated. I see we 15 seconds ago the balance of this contract was the link tokens was deposited for this contract. Okay, so I think this no, something is wrong. I see an error. Let's fund this upkeep. Maybe it's need more money. Wait a second. Usually it works okay with the minimum balance, but today it doesn't work. Okay, so yeah, we deposited some money and our upkeep is in active state. And I think that we see first as execution. We see that this upkeep was performed. What does it mean? It means that our employee got some money from this payroll contract. And if we open our employee address, we'll see that 36 seconds ago, it got a salary. And it was in automated way, so based on time rule. And if we come back to this upkeep page, we must see other performs. Yeah, we see that every minute this upkeep call this payroll contract function, which is responsible for making a payment for employee. And if we come back to employee address and update these transactions, history, we must see here a third payment. We need to wait a bit because it can't be updated very quickly. Let's update. Okay, we'll come back to this page to verify that it was the third payment was done. But what about the second option of automation? It called custom logic automation. So I don't want to use some cron expression to automate my contract because the logic can be more the condition of execution in automated way can be complicated, and I want a keeper to check this complex logic. So we will create. I go back to transactions history of employee, and we see here a third payment. So automation works. Once again, I want to automate this process in another way. I want to automate using a custom logic automation. To do this, we need the contract which we need to automate must implement some interface which Chainlink provides. And to do this, I prepared a second smart contract. It's called Payroll Chainlink Automated Contract. And this smart contract implements automation compatible interface provided by Chainlink. And this interface is very simple. According to this interface, my automation contract must implement check upkeep function and perform upkeep function. We saw these functions when we was researching Chainlink automation solution. And this smart contract is just a wrapper around payroll contract. Inside the storage of this wrapper, we see a link to payroll contract. But this contract wraps. So we have a check upkeep function. It wraps function check next payment, which is implemented in payroll contract, and perform upkeep function wraps check next payment function. That's it. And we need to deploy this contract. So let's do this. And to do this, I have a script. It's called deploy payroll Chainlink automated. And here we need to copy the payroll address. We need to copy the payroll address. Give me a second. I think it's easier to redeploy the payroll and its wrapper, and I will do it. It will be easier. Okay, so I will run this script, and this script will deploy payroll contract and payroll Chainlink automated contract, which is wrapper around payroll, which implements interface provided by Chainlink. And payroll contract was deployed. Let's open it. Yeah. Payroll automated contract was deployed. Let's open it. Yes. And we still have some employee. It's our third tab from Polygon Scan. So now we need again to hire employee, but in our new payroll contract. We will call a hire employee function again, but we need to update payroll contract. Let's do this. Hire employee. Because this is a new contract which was deployed 1 minute ago. That's why I don't have our employee, because the storage of this contract is completely new. Okay, I successfully called hire employee function, and again to read contract tab and pass here an employee address. We see that it was hired. But now we will automate this contract in using custom logic, not time-based logic. We need to choose here trigger type. Go next. Here once again, we need to pass the target contract address, but we will not pass payroll contract address. We will pass its contract, its wrapper address, which is called Payroll Chainlink Automated, because this contract implements the interface. Yes. Okay. And once again, we need to call this upkeep. We will call it upkeep custom logic. Okay. I will use first bytes of contract address, and I want to deposit one link token here. And here we need to pass check data. If we look at this wrapper contract, the arguments of check upkeep function and perform upkeep function are in bytes. If we compare check next payment and make next payment function, there is employee address. But according to Chainlink custom automation, we need to pass address in hexadecimal format. So we need to convert employee address to hex. I have a function prepared for this, which I need to call. It will convert address to address in hex format. Prepare payload. Something is wrong. Give me a second. Prepare payload. Okay. Sorry, give me a second. Something wrong with my script. Okay, everything is okay. So here we see our address in bytes format, and that's it. We can. But first, I need to fund payroll contract with some link to pay salary. Okay, 1 second. We will send this amount of matics. And also I need to send some links to this contract, to payroll contract. Sorry, I need to send to a wrapper, I think. Okay. Let's send one link. Okay, I think that's enough from our side, and we can create upkeep finally. Let's do it. Okay. We here already 1 hour out, but I will finish soon. Sorry for this, but the topic is complicated, so we need this. Okay, so yeah, we created upkeep. We will see here, we will see this custom logic upkeep. Yeah, we see it, and this upkeep is in an active state. And if we go to the history, we see that we see already first perform upkeep function. This is our employee have already received the first payment, and this first payment was created using custom logic automation. So yeah, we see that 1 minute ago he got his first salary. What is the difference between time-based automation and custom logic automation? So automation doesn't check some conditions. It can only run execution according to some schedule. But if we implement custom logic automation, we can implement in our smart contract the logic, the complex logic. And in this case, our logic checks that the payment interval has passed, and also we check that the contract between employer and employee is in active state. But this logic can be very complex if you want. And when we spoke about use cases, we spoke about limit orders, and the condition of execution of limit order is very complex. And using custom logic automation, it can be implemented, and using time-based automation, it can be implemented. If we come back to this upkeep page, we will see in the history, yeah, so the second payment was made. So the second salary was paid for employee, yeah, 2 minutes ago and 1 minute ago. So our automation, it works. But I want to go further, and I don't want to use any UI to create these upkeeps, to create these bots. I want only I want to implement logic on smart contract. So this logic will create these upkeeps on chain, and it is very useful because we don't need to. If we imagine that if we have 200 employees, we can't. It is very difficult to create manually upkeeps for every employee using UI or SDK. It is better to implement this logic on chain, for instance, and here I prepared a high employee function, which we can admin of this payroll contract can only call this hire employee function, and employee will be hired, and upkeep bot will be created for this employee, and automation will start. So it will be much more friendly, much more. It is a much more powerful way to automate something. Completely decentralized without a centralized point of failure like UI or SDK or centralized server. So this we have already deployed this payroll Chainlink automated contract, and it already has employee function. And basically, this function is a wrapper around payroll hire employee function. But also it has some additional logic. It creates upkeeps on chain. So here we see that upkeep is created on chain. And these fields are similar to the fields which we saw in the UI, but but this logic is implemented on chain in Solidity. So let's hire employee using this wrapper contract and without touching this UI. So for this, I have a script for this task. So I have a script called hire employee with upkeep. And here I need to pass actual payroll Chainlink automated contract address. And also I need to hire employee. I have already hired employee with address ending on FB4, and now I want to hire another employee, for instance, employee with this address. And also I want to hire another employee with this address. Employee 2 and employee 3. So I want to hire these employees. And I want to pay them salaries in automated way. So everything is prepared. So we have automated contract address and 2 employees. But first, let me deposit some additional money to payroll contract because its balance was drained because it already paid a lot of money to employees. We need to add some additional matics to this contract. Okay, this is the address. I want to transfer him this amount of matics. It's enough for a lot of payments. Okay, so let's call this script. I think it will run successfully. But firstly, let me check. Yeah, we deposited some money to payroll contract because payroll contract pays salary from payroll's contract balance. Salary is paid. So let's hire employee with upkeep. So I need to call this script. Let's do it. Okay. First employee was hired, the second employee was hired. So we see 2 transactions here. Let's open the transaction history of payroll automated contract. These 2 transactions must appear here soon. Okay. Yeah, we see 2 transactions, hire employee and hire employee. So 2 different employees was hired. And if we go to payroll contract, let's see if maybe some payments have already done for this employees, for some employees, for these new employees. Also, I want to open in Polygon scan these 2 employees. This is the first one, and this is the second one. Oh, sorry. First one, second one. And if we go to internal transactions, they must get some money already. Not yet. Let's check Chainlink Automation console. The upkeeps must be created and we must see them here if everything is okay. Yeah, I see 1 employee with address ending D5. Yeah, 1 upkeep and the second upkeep. I think that everything is okay and our upkeeps was created. Yeah, first upkeep for employee was created and the second upkeep was created. And in history, I see that there is a perform upkeep, 1 perform upkeep for each employee. So they got their first payments. But I did, as you see, I didn't use Chainlink UI to create these upkeeps. So these upkeeps, these jobs was created automatically because my smart contract do it on chain and Chainlink Automation Network uh, saw this and created these keeps. And if we go to on Polygon scan and see employees history, see that 1 minute ago, first employee got money and the second employee also got money 30 seconds ago. So automation is working. And after another minute, the second payment would be made. Yeah, we see that the second performed keep was executed. So the second payment was made and the interval here is 1 minute as expected. So everything works nicely. So here I want to stop this demonstration. So let's finalize. So during this talk, I give a brief introduction to smart contract automation infrastructure. We discussed why smart contracts need automation. We discussed a different approach with Chainlink and Gelato, and we also implemented automation of payroll contracts, and we implemented it in 3 different ways. We implemented it manually, so I acted as an administrator and paid salary manually. Then we automated it using Chainlink time-based automation using UI. And then we automated our payroll contract using custom logic-based automation, also using UI. And at the last, we automated payroll contract using only on-chain logic. And we didn't touch UI or didn't run any JavaScript code which use SDK. So we done it in most decentralized way and automated our process. But this payroll contract is a very simple use case, and you can think about other use cases more serious. Use cases connected with decentralized exchanges, connected to DAO processes, and etc. etc. And possibilities here are limitless, and this is great. But unfortunately, we didn't discuss the automation solution offered by Open Zeppelin it tenderly, but it's too much for this topic, for this talk, and maybe I will do it in next lectures. So that's it. Thank you for everybody and for people which will watch this lecture in records. And if you have any questions, you can find my LinkedIn account on event page and write me, and I will send you a presentation, for instance, and the code which I used during this coding session. So thank you everybody. I finished. I have finished. So the last 2 people which left, which are here, maybe you have some questions for me. I can answer, or we can finish the talk. Okay. Okay. So let's finish. Thank you everybody. Bye bye.